Question number 1. The nitrogen is heated in a balloon which expands slightly. Which statement about the molecule of nitrogen are correct? So if you're increasing the temperature, so the temperature is directly proportional to the volume and kinetic energy. So by increasing temperature, the volume will increase, so the distance between the molecule will increase. And by increasing temperature, the kinetic energy will increase, so the number of collisions of the molecule will increase, their speed of movement will also increase. So here, statement number 1, they move further apart. It is correct. Why? Because volume is increasing. And they move more quickly. Why? Because kinetic energy is increasing. The statement number 3, they remain same distance apart. So they will move away from each other. So that's why their distance will increase. So it is wrong statement. And their speed remain unchanged. So if the temperature is increasing, kinetic energy is increasing, their speed is also increasing. So 1 and 2 statement are correct. So A is our correct option here. Question number 2. The diagram represents some element, compound, and mixture. So in the diagram number 1, that's the compound. Why? Because when different atoms join together by a chemical bond and make a pure substance, that is compound. And when the two different type of compound mix together without any chemical bond, that is mixture of the compound. So number 2 is a mixture of the compound. Number 3, when the different atoms, they all belongs to the same element, means similar type of atom grouped together, so that's making element. And when the different atom group together without any chemical bond, that's making mixture of element. So which row describes the number of the substance? So here we can see in a column 1, so in the column 1, that's number 1 is related with compound. So that's why our A and C are element. It's a wrong option. So we're going to see this, the B and D option in the number 2. So in the number 2, this is the mixture of compound. So we confirm our answer. Why? Because the D is a wrong option here. So we can confirm our answer in the column 2. So in the column 3, we shall verify our answer. So element, the column 3 is element. So here B is further confirmed. And group 4, the mixture of the element. So B is our correct option here. Question number 3. Two atoms X, Y have the same mass number, but they have a different atomic number. So which statement about the X and Y is correct? So atomic number is the number of the proton, while the mass number is the number of the proton plus number of neutron. So on the basis of this information, we can see that they have the same number of the proton. It's a wrong statement. They have a different number of the proton. Why? Because they have the different atomic number. So B statement, they have the same number of electron. So number of the proton and number of electrons are always same. So that's why they have different number of electrons. And they are in a same group of periodic table. So if they have a different number of electron in their outermost shell, so they cannot be in a same group in a periodic table. So the D option, they have different number of neutrons. So we're going to see that how it is the correct statement. Let's suppose, for example, if they have a different proton number, like the X contain, let's suppose it contains 5, and the 5 proton, and Y contains 6 proton. In the same way, if you can take number of neutron to get same atomic mass, so if you take any number which is same for X and Y neutron number, it's not possible for you to get the same number of the atomic mass. So in that way, you have to take different neutron number to get same atomic mass number. For example, we're going to take X as a 6 and the Y as a 5. If you add them together, 5 plus 6, and this is equal to 11 atomic mass. So that's why we have to take different neutron number to get same mass number. So that's why it is D is our correct option here. The question number 4. A sample of a pure iron contains 3 isotopes. Now, these isotopes, we are having the atomic mass, relative atomic masses given there, and we have their percentages are given there. So percentage abundance. So relative atomic mass formula is equal to, so the mass of the percentage abundance multiply the mass of isotope divided by 100. So we're going to put this value, for example, a relative atomic mass is given there, 55.9. That is equal to, so we have first isotope, the relative abundance is 2, percentage abundance is 2, multiply N, because atomic mass is not given there. In the second isotope, that's plus the 54 multiply relative percentage abundance, that is 6. And plus third isotope, atomic mass, that's 56 multiply percentage abundance 92. So divided by 100. So we're going to solve this question. So 100 is dividing, other side it will multiply. And after solving, we will get this value. So that's our 5,590 minus. So 5,476 is equal to 2n. So we will get the 2n is equal to 114. So we're gonna divide 2 at both sides and to get that the value of n. So that's value of n is equal to 57. So here C is our correct option here. The question number 5. Magnesium oxide is a white solid at the room temperature and pressure. So part of the structure of the solid magnesium oxide is given there. For example, we can see that the black dot is a magnesium that's smaller in size, while the white is oxygen, which is larger in size. So we can see the magnesium with the +2 oxidation state. So total number of electron in magnesium are 12. When it will give 2 electron, so that will oxidize to get oxidation state, and that's +2, and total number of electron become 10. So electronic configuration will become 2 and 8. And in the same way, the oxygen, it will take 2 electron and total electron will become 10. So in the first shell, 2 electrons, second shell, 8 electron. So you can see that number of electrons are equal. So we're going to check that which statement is correct. So magnesium ions are smaller than to the oxide because they contain fewer electrons. So you can see that number of electrons are same in magnesium and oxygen. So that's why that's the wrong reason. So the oxide basically taking 2 extra electron. So in their outermost shell, that's why they have larger size. So that's why it is the wrong statement. The number 2, the magnesium oxide have a good electrical conductivity when in the molten state. Why? Because ion can move. So when they ionic salt or ionic substance, when they melt, so their ions can move in a solution, in a melted molten state, not solution, that's a pure form. So they are moving in a molten state, so they can conduct electricity. So that's a correct statement. Number 3, magnesium oxide have high melting point because the strong electrostatic force of attraction between ions and the delocalized electron in a joint lattice. These delocalized electrons are present in a metallic bond. What about this magnesium oxide is an ionic solid, so that contain ionic bond. So that's why it is wrong statement. So the D is our correct option. Why? Because statement number 2 is correct. The question number 6. In which molecule are all outer shell electrons involved in covalent bonding? So you can see that if there is a chloride molecule, and in this chloride molecule, only outermost 1 electron is shared between these 2 chlorine atoms, and they're getting octet rule. So that's why the rest of 6 are not shared in covalent bonding. So that's the wrong option. And in the B, the carbon contain outermost electron 4. And it's completely shared with a 4 hydrogen atom. What about the hydrogen contain outermost one electron and it's shared with a carbon. So both are getting their stable electronic configuration. So that's why the B is our correct option. And in the C, we can see the hydrogen is sharing complete, but the chlorine is sharing only one electron. What about rest of 6 are not being shared? So that's why that's the wrong option. And in ammonia, the nitrogen is present in a group 5. It contains outermost 5 electron, and it's sharing 3 with the 3 hydrogen, while one lone pair stay normal. So it's unbonded lone pair. So 2 electrons are not being shared. So that's why it is a wrong option. The question number 7, which row describes the property of silicon oxides? So silicon oxide is a giant molecule. Why? Because it's making covalent bond with a tetrahedral arrangement. And due to this, a repeated covalent bond is giving high melting point and high boiling point. So on the basis of this property, we can see the joint covalent structure. Yes, it has a joint covalent structure, and the melting point is comparatively high. So C is our correct option here. The question number 8, which row describes the structure of solid metal and explain the property of that? For example, the solid metal is basically the metallic atom on lost electron. They contain extra electron in their outermost shell. They're losing this extra electron to get octet rule or stable electronic configuration. And in this way, they are making positive metallic ions, while free electron get delocalized between positively metallic ions. So that's why these free electron can conduct easily heat and electricity. These are malleable and ductile in nature. They have lustrous and hard structure. So on the basis of this property, we can see that option A, the lattice of negative ion. So the metallic solid is not making negative ion. Every metallic atom is losing to 1 or 2 or 3 electron. So they're making positive ion. So that's why A and B are wrong option. And in the C, they're making positive ion in a sea of electron, and they can conduct electricity because their ions can move. It's a wrong option. Their electrons can move. Ions cannot move. So the D, the lattice of positive ion in a sea of electron is correct. It's malleable. Why? Because their layer of electron can slide over each other, and they have a property to convert into thin sheet. So that's why the D is our correct option. We're going to move to the question number 9. What is the formula of potassium oxide? For writing the formula of potassium oxide, we can see that the potassium contains +1 oxidation state, while oxygen contains -2 oxidation state. Why? Because it's present in the group 6. So it will take 2 electrons to get 8 electrons in outermost shell. So oxygen always get -2 oxidation state, while potassium, which contain outermost 1 electron, it will get +1 oxidation state. We're going to do a cross method. So -2 can write below the potassium, and that will produce K2O. So this way you can see to satisfy the -2 oxidation state of oxygen, there is need for 2 plus ions of 2 plus charge of the potassium. So that's why it can satisfy each other. So then it's making the formula K2O. D is our correct option here. The question number 10. A dilute aqueous solution of the sodium bromide is electrolyzed using inert electrode. Which row identify the product at the cathode and at the anode? So you can see that for understanding of electrolysis, we should know this information. For example, if this is the molten salt, so there's only the salt ions are present, and in this way, the positive ion will reduce at cathode, negative ion will oxidize at anode. But if it is dilute solution, so in this way, the concentration of water is more in the dilute solution, so the hydroxyl ion will oxidize at anode and produce water and oxygen. While at cathode, you need to compare the hydrogen with the metallic ions. So this metallic atom, if that the metallic atom is more reactive than to the hydrogen, mean it's above to the hydrogen in the reactivity series, so the hydrogen will reduce at cathode in the form of hydrogen gas. So in the same way, if you have a concentrated solution at anode, there is going to be, that's a negative ion of a salt. What about at cathode? You need to compare the metal in this salt with the hydrogen in the reactivity series. So we're going to see this question. For example, we have a dilute aqueous solution of the sodium bromide. And in this way, if it is dilute, so it's confirmed at anode, there's oxygen is going to produce. Why? Because water molecules are more. And in this way, at cathode, so you can compare, you can see like sodium is more reactive than to the hydrogen. So the hydrogen will reduce easily. And in this way, two hydrogen ion, they will reduce more easily and produce the hydrogen gas. So in that way, the C is our correct option here. We're going to proceed to the question number 11. And that the question number 11, we can see that the aluminium is extracted by electrolysis as shown there. In this electrolysis method, we have the graphite anode and we have a graphite cathode and we have aluminium oxide. This is dissolved in cryolite solution. So that's making electrolysis. Now in this way, which row shows the ionic half equations of a cathode and anode? So we can see that the cathode with a +3 oxidation state, it will take 3 electron and reduce at cathode. But it's wrong. Why? Because 3 electron is supposed to be in the reactant side. So that's why A and B options are wrong. What about C? So the aluminium will reduce and take 3 electron, and this will deposit at cathode. What about at anode? The oxygen with a negative oxidation state, it will give 4 electron and it will oxidize at anode to produce oxygen gas. So that's why the C is our correct option here. The D is wrong. Why? Because oxygen is losing 4 electrons. So electrons should be on the product side, not on reactant side. The question number 12. The reaction pathway of a diagram of exothermic reaction is given there. In this exothermic reaction, we can see, so the exothermic reactions, the energy is moving from system to surrounding. And in this way, we can say that the work done by the system. And in this way, the product energy will always be less than reactant energy. Why? Because the energy is moving from reactant to the outside. And we are representing this with a negative sign. So here there's a diagram is represented. So number 1 is a reactant. Why? Because it's greater than to the product. So number 4 is a product. And the activation energy is a 3. Why? Because minimum energy is needed to convert reactant into the product. And while the difference of energy of reactant to the product is an enthalpy change, that is variable H. This is number 2. So we can identify which option is correct here. So number 1 is our reactant, number 2 is our enthalpy change, number 3 is activation energy, and 4 is a product. So the A is our correct option here. The question number 13. The equations of a complete combustion of ethene is shown there. So when the ethene will burn in the presence of oxygen and produce carbon dioxide and water, so we can calculate the total energy of a bond energy in this chemical reactions. So we have a concept, the energy absorbs in breaking bond in the reactant side, while the energy releases in making bond in the product side. So that's why energy absorbed, we are representing with a positive because it's going to the system, while energy release, we are representing with a negative because it's going out of the system. So in this way, we're going to calculate first to the reactant side. So you can see in the reactant, we have an ethene structural, that's a formula. So now in this way, you can see the double bond between carbon-carbon atom. So there's the one double bond is present. So that's why we can use 612 from the table. That's a value of a carbon-carbon atom. While carbon and hydrogen, there are 4 carbon and hydrogen atoms. So 4 multiply 412. And plus, we have a 3 oxygen double bond. So that's 3 multiply 496. And we'll get the total value 3,748. In the reactant side, this much of energy will absorb by breaking bond. And in this way, in the product side, the 2 carbon dioxide molecules are produced. Each molecule contains 2 double bonds, so that will become total 4. 4 multiply bond energy 743 plus each water molecule contains 2 hydrogen and oxygen bond. So total are 2 water molecules. So in this way, total will become 4 multiply 463. And in this way, we solve that, and that's the total values of 4,824. Now, this value, we are going to compare. For example, in the reactant side, the energy is absorbed. This is 3,748 minus in the product side, energy is released. That's minus 4,824. And our total enthalpy change is what? Minus 1,076. And that one, this is our exothermic reaction. Why? Because answer is coming in minus, energy released more as compared to the energy absorbed. So B is our correct option here. The question number 14. The magnesium react with the hydrochloric acid to form magnesium chloride and hydrogen. Why does the magnesium powder react faster than to the magnesium ribbon? So if you're decreasing the size, and the surface area is increasing, and number of the particle are also increasing. So in this way, if there's a more surface area, more number of collision, or more number of particle, more number of collision. So that's why the rate of reaction will increase. So the magnesium atom is in a powder state, have a lower activation energy. Now this activation energy does not depend on the size. It has a particular the energy which converts reactant into the product, and especially some catalysts are decreasing the activation energy of molecule. So that's why it is wrong option. Now the powder has smaller surface area. It's a wrong option. The powder has a larger surface area. By decreasing the size, surface area to the volume ratio increasing. So the magnesium atom is in the powder state, has more frequent collision with acid particle. So within the given volume, if you're decreasing the size, the number of the particle are increasing. So number of collisions are increasing in this way. So that's why C is our correct option. So magnesium atom in the powder has a greater kinetic energy. So the kinetic energy depend on the temperature. It does not depend on size of the particle. So that's why the C is our correct option here. The next question is about that's our contact process. So you need to know that what are the conditions needed for our contact process. So that's a knowledge-based question. We need the catalyst, that's a vanadium oxide, and we need a pressure as 2 atmosphere pressure, and the temperature is 450 is needed to keep the reaction in the forward direction. So that's C is our correct option here. The question number 16. A student heated hydrated copper sulfate, and the blue crystal changed to the white powder. So for example, the blue color is a hydrated condition. That's a hydrated. For example, copper sulfate with a 5 water molecule, and that's making in a hydrated condition, a blue color. Now, if you heat it, that water molecule will evaporate, and this will become a white powder. How the student can convert this white powder into the blue? So by adding water. So if the student will add water in that, this will once again convert into reversible reaction by reversible reaction into hydrated form. So that's why the B is our correct option. Add the water to the white powder. This will convert from anhydrous to hydrated state. So the B is our correct option. We're going to proceed to the question number 17. In the question number 17, which reaction of a hydrochloric acid is a redox reaction? So the certain type of chemical reaction in which the oxidation state and of some chemicals is changing from reactant to the product side. So in this way, some chemicals are oxidizing, some are reducing, and in this way, if there's an oxidation and reduction reaction, both taking place in a one chemical reaction, that is called redox reaction. To know that this chemical reaction is and the redox reactions, so we can see that, for example, if we have magnesium carbonate react with a hydrochloric acid and produce magnesium chloride, water, and carbon dioxide. So we need to write their oxidation state. If these oxidation states are changing, so we can identify either the oxidation or reduction reaction is taking place or not. For example, we can have the magnesium is present in the group 2 in the periodic table, and that contain +2 oxidation state. While the oxygen is present in the group 6, it contains 6 electrons in outermost shell. It will take 2 electrons to make it 8. So that's why it always present in -2 oxidation state. Now here, the carbon, if you're doubtful about carbon, so we can also find by this method, at the right side, you can see magnesium +2. We can write carbon is X, we don't know, and minus the oxygen is -X. Is equal to 0. Why? Because there's no charge on magnesium carbonate. So we can calculate -6 and +2, that will become -4, and -4 on the other side, it will become +4. And in this way, X is equal to +4 oxidation state. So carbon will go with the +4 oxidation state. So in this way, you can also find the unknown oxidation state. What about hydrogen? +1 oxidation state, it's present in the group 1. Chlorine always will be with a -1 oxidation state. If you're going to compare from reactant to the product, and you can see that there's no change from the reactant to the product of their oxidation state. So that's why A is not participating as a redox reaction. So that's why it's a wrong option. In the same way, we're going to calculate in a magnesium hydroxide is reacting with a hydrochloric acid and produce magnesium chloride and water. So if you check that, the oxidation state from reactant to the product is not changing in any atom. So you can also write in a hydroxyl with a -2, oxygen always with a -2, hydrogen with a +1 oxidation state. So in this way, that's not changing from reactant to the product. So that way we can say these are wrong option. And C, if you calculate in this criteria, that's also a wrong option. While you see that in the D, the magnesium with a 0 oxidation state in the reactant. But in the product, when it will react with the chlorine, so that will produce magnesium chloride, and that is magnesium is with a +2 oxidation state, chlorine is -1 oxidation state. So in this way, what happened? The magnesium oxidation state increased from 0 to +2. So it means magnesium is oxidized. What about the hydrogen? You can see +1 oxidation state. So this +1 oxidation state, it convert into 0. And in this way, why? Because hydrogen is reacting with the hydrogen only. So in that way, so that one, there's a 0 oxidation state. So in this way, it reduced because it has taken 1 electron. So in this way, what will happen? So that the hydrogen is reduced and magnesium is oxidized. Now, oxidation and reduction both are taking place in a one chemical reactions. So we can see the D is a redox reactions. We're going to move to the question number 18. Which oxide is amphoteric oxide? So when the metal react with the oxygen, they produce the basic oxide. So when the non-metal react with oxygen, they produce acidic oxide. For example, the carbonic acid or carbon dioxide will produce a carbonic acid. So, but there are certain type of metal which react with the oxygen and they produce amphoteric oxide. For example, zinc and aluminium. So zinc oxide and aluminium oxide, they are behaving both acidic and basic. So that's why these are called amphoteric. So A is our correct option here because that's contain aluminum oxide. This is our amphoteric oxide. We're going to move to the question number 19. The fourth statement about the strong acids are listed there. Now, these strong acids are completely dissociate in a solution, and they make high concentration of the hydrogen ion comparatively weak acid. So second, there are some examples like hydrochloric acid, nitric acid, sulfuric acid, and these are strong acid. So statement number one, they react with the carbonate to form carbon dioxide. That's a correct statement. Why? Because hydrochloric acid is reacting with a marble stone and it's releasing carbon dioxide, and that's marble stone get corroded by the hydrochloric acid or sulfuric acid. And in this way, this is correct statement. And number two, they completely dissociate in an aqueous solution. It's a definition of strong acid. And number three, they react with ammonium salt to form ammonium. Now, this ammonium salt is considered as a weak base. It cannot fully neutralize the strong acid. So when the strong acid would react with the ammonium salt, and the product will be same. So that's why we consider they do not react with the ammonium salt. So that's why number four statement, they are proton acceptor. It's a wrong statement. And actually, they are proton donor. So that's why the statement number one and two are correct here. So A is our correct option here. We're going to move to the question number 20. Which reaction mixture will produce a precipitate? The precipitate means insoluble salt. For example, when the aqueous sodium carbonate react with the aqueous copper sulfate. So these are soluble in the water, but they are producing copper carbonate, which is insoluble salt, and that is producing precipitate. What about the sodium sulfate is soluble, so we can filter and get separate the copper sulfate from the sodium sulfate solution. So A is our correct option. What about the B option? Sulfuric acid react with the sodium hydroxide, and this is going to produce a sodium sulfate in water. Now, this sodium sulfate is soluble in water. And nitric acid react with the magnesium oxide. That is producing magnesium nitrate. So that's also soluble in water. So this magnesium nitrate, and this is going to produce that form. Let me correct one part there. So that's producing two. That's a magnesium sulfate. The second, the D is also wrong. Why? Because copper oxide is reacting with the sulfuric acid and producing copper sulfate. It's soluble. So in that way, A is our correct option here. We're going to proceed to the question number 21. Which set of element shows the change from metallic to non-metallic character across the period? So metallic character usually decreasing if you're moving from a left to right in periodic table. So we can see that option A is wrong. Why? Because beryllium, magnesium, and calcium, they all belongs to the group 2. So they're not moving in a period. So that's why it is wrong. Next is the halogens like fluorine, bromine, and iodine. They all present in group 7. They're not present across the period. So that's why it's a wrong option. C is the wrong option. Why? Because it's moving in opposite directions, mean group 6 to group 3 to group 1, like oxygen, boron, and lithium. So that's moving in an opposite, not from left to right in a periodic table. So what about the D is a correct option? For example, sodium is a group 1, silicon is a group 4, and the chlorine is a group 7. So if you're moving from sodium to the chlorine, the metallic character decreasing from left to right in periodic table. So what about C? It's increasing. So that's why D is our correct option. The question number 22. A sample of ethanoic acid and a sample of hydrochloric acid, they have a same concentration. How do the hydrogen ion concentration and pH of ethanoic acid can be compared with each other with the hydrochloric acid? So we can see that hydrochloric acid is a strong acid. It will completely dissociate, and this will produce high concentration of the hydrogen ion, and its pH value will be low as compared to weak acid. And in the same way, ethanoic acid is a weak acid. This will partially dissociate and comparatively produce low concentration of hydrogen ion, and the pH value will be higher. So in this way, ethanoic acid compared to the hydrochloric acid, the hydrogen ion always will be lower, and the pH value will be higher because the number of hydrogen ion are low. So C is our correct option here. The question number 23. What is the typical property of transitions element? So these transition elements, they are bonded together by the high unpaired electron. They are delocalized electron present in between these ions. So that's why they're having strong, there's force of attractions of these delocalized electron. So they have a high melting point, high boiling point. They're a good conductor of heat and electricity. And they can easily withdraw the electron from the reagent. So that's why we are using them as a catalyst. So the option A is correct here. So they can act as catalyst. While they are the good conductor of electricity, so option B is wrong. They have high melting point. Option C is wrong. And they have high density. So that's why option D is wrong. So A is our correct option here. We're going to move to the question number 24. Which statement about the copper or aluminium is correct? So aluminium is a more dense than the copper. So you can see that the aluminium which contain an oxidation state, that is, the aluminium with a mass is 64. Is a greater than, that's a copper with a mass is 64. Is a greater than the aluminium with a mass of 27. So we can see the aluminium is containing more mass as compared, the copper is containing more mass as compared to the aluminium. So you can say the copper is a more denser than to the aluminium. So that's why A is the wrong option. Now, aluminium is less reactive than to the copper. Now, that's a wrong statement. Why? Because if you can see that the right side in the reactivity series, so you can see aluminium is coming above to the copper. So we can say the aluminium is more reactive than to the copper. So that's why B is a wrong statement. And the D is a wrong statement. The copper has poor electrical conductivity. So copper is a very good conductor of electricity. That's why we are making the wires of copper. So that's why it is a wrong statement. The C is our correct statement, why the copper has high ductility. So that's why we are applying pressure on the copper, and these the atoms slide over each other and get the form of wire. So that's why it has a high ductility. There's another reason why the coppers have a high ductility as compared to the other metal due to its specific arrangement with a face-centered cubic structure. So that's why they have a more internal plan angle to slide over each other. So that's why they have high ductility. So C is our correct option here. The question number 25. The water from the reservoir flow to the waterworks where the purification process 1 take place, followed by the process 2. When we see that the water purification, so the step number 1 is what we are performing filtration to remove insoluble impurities from the water. While the process 2, we are applying, and that's the last process, so we are applying chlorine so to kill the bacteria. So in this way, the process 1 is supposed to be what? That is we need filtration, while in the process 2 is a chlorinations. So B is our correct option. What about here? The wrong option is fractional distillations. So the fractional distillation is used to separate the different chemical mixture on the basis of their different boiling point. For example, crude oil contain the different fractions of a hydrocarbon. So we are separating that. It's not applied on the water purification. So that's a wrong option. So here, the B is our correct option here. The question number 26. Now we need to identify on the basis of the statement the reactivity order of different metals. For example, the calcium react with cold water to produce hydrogen. So it's a highly reactive. Why? Because if it can react with the cold water, So, and can produce of the hydrogen. So it means it's the most reactive metal. Okay. Next, the lead reacts slowly with the heat. So when heated in the air to form of oxide, but in almost no reaction with the steam. So we got some idea on the basis of these two. So we're going to compare this value to the next. Now, silver does not react with either air or water. So it's completely not reacting. So it means it is least reactive. Now, the zinc react when they're heated with the steam to produce hydrogen. So you can see that, what about in lead? It's not reacting with the steam. What about the zinc is reacting with the steam? So it means the zinc is more reactive than lead. And then the silver is less reactive than lead. Why? Because it's not reactive. So in this way, we got the sequence. The calcium is highest reactive, then it's the zinc, and then it's the lead, and then the last one is silver. So we're going to see that in a reactivity series there. So we can also compare these values in a reactivity series. And here, the least reactive is what? That is a silver. And what about further is lead and then zinc, and then the most reactive is calcium. So why? Because it can react with the cold and hot water. So that's why it is the most reactive. So this way you will take pencil and by the use of this statement, you can compare first and get the numbers and then proceed for the option. So C is our correct option here. We're going to proceed to the question number 27. The block of magnesium are attached to the bottom of the steel board to prevent rusting. Which equation describe to the change that prevent the steel from the rusting? So that's a phenomena. And in this phenomena, we're going to do what? A more easily oxidizing metal is called a sacrificial metal. So it's attached to the steel board or the metallic board. So which should be more oxidizing as compared to the metal which is present in the body of the board. So when it will come and interact with the water molecule, so this magnesium will get first oxidized and release the electron, and it get corroded. And in this way, the actual structure or original structure of original body of your board will stay protected. Now, in this way, we can see that in the steel, there's iron, and in the right side, in the reactivity series, so magnesium is more reactive than to the iron, so that will easily oxidize. So in this way, the D is our correct option here. So the magnesium will easily oxidize, and in this way, this will react with the oxygen and produce magnesium oxide, and in this way, this will get corroded. What about the iron will be protected, or steel will be protected? So D is our correct option. So A is the wrong option. Why? Because the magnesium is being used to protect iron. So B is the wrong option. Why? Because it's not purification process of iron. And magnesium, this one in the C is our wrong option. Why? Because it's already in oxidized state. So it's not reacting with iron. It's reacting with the oxygen from the water or air, and that produce magnesium oxide. So D is our correct option here. We're going to move to the question number 28. Which statement about the extraction of iron in blast furnace are correct? So this question is about the metallurgy of iron. So the temperature inside of the blast furnace is increased by the burning of carbon. So when we are burning the carbon, this is an exothermic reaction, so that's the temperature will increase. So that's a correct option. So iron oxide is reduced to iron by carbon monoxide. So in this way, we can see iron oxide, that's the ore of iron metal. That's reacting with the carbon monoxide, and it's producing iron plus carbon dioxide. So the carbon monoxide is more reactive than to the iron oxide. It will snatch oxygen from that and produce the carbon dioxide while the iron get purified. So 1 and 2 statement are correct. Now the thermal decomposition of a calcium carbonate forms slake. So we define the slag is what? For example, the calcium carbonate, it will dissociate into the carbon dioxide and copper calcium oxide. Now this calcium oxide is combined with the silicon dioxide. And this produce a salt. Why? Because calcium oxide behave as a base and silicon oxide behave as an acidic. They combine each other, and this is a neutralization reaction. This will produce a salt, calcium silicate, and this is going to produce what? Slate. Now, this is a wrong option. Why? Because in a statement, it's saying directly the calcium carbonate will form slake. So that's a wrong option. So number 4, slake react with the acidic impurity. So it's a salt. It's not reacting with the acidic impurity. So that's why 1 and 2 are correct statement. So A is our correct option here. The question number 29. Which statement about the water are correct? So the water has the transparent, and it has no color, and it has 7 pH value, and that's a colorless, odorless, tasteless, pH value 7. So these type of properties of the water. We're going to check that. So the option number 1, the tap water has fewer impurities than to the distilled water. So that's a wrong option. Why? Because distilled water has 0 salt. So that's why the fewer impurity, that's the wrong statement. So the statement number 2, the tap water will turn anhydrous copper chloride pink. So and this is also a test for water. For example, we have a copper chloride without water. This is called anhydrous. If you're going to add the water molecule in that, that will produce the copper chloride hydrated form. And that will turn into the pink color. So this is correct statement. And number 3, that domestic water supply is treated with the carbon to kill bacteria. So carbon does not kill bacteria. It's basically the chlorine will kill bacteria. So that's why it is a wrong statement. So number 4, the phosphate from the fertilizer can cause deoxygenation of water. So it's basically, this is correct statement. Why? Because if there's a high fertilizers out there, so, or high phosphates or high nitrates are there in the water, this will cause to increase of algae. When the algal growth increase, it covers all the surface area of water, so the sunlight cannot penetrate into the water. So aquatic plant cannot perform photosynthesis and they die. When these aquatic plants die, so the aerobic bacteria start growing on the dead bodies of aquatic dead bodies of the plant, and they absorb all oxygen. And in this way, the oxygen decreases in the water and the animal die. This whole process called eutrophication. Now, this eutrophication is caused by high phosphate, so that's why it is possible. So the statement number 2 and 4 are correct here. So C is our correct answer here. We're going to move to the question number 30. The oxide of nitrogen form in car engine and are removed by catalytic converter. So which equation represent a reaction that occurs in a catalytic converter? So what is a catalytic converter? It basically converts harmful gases to the harmless form. For example, we have the nitrogen in the fossil fuel. When the fossil fuel burn, and this is producing nitrogen oxide. Now, this nitrogen oxide is basically harmful. Why? Because it damages the respiratory tract and it causes irritation and asthma condition. So that's why catalytic converter is doing what? It is converting the 2 molecules of nitrogen oxide into a nitrogen and oxygen. This is less harmful, or you can say harmless gases. And in the same way, the carbon monoxide, this irreversibly combined with the hemoglobin in the red blood cell, and it blocked the hemoglobin, so it cannot carry the oxygen. So that's why this is lethal for health. So the catalytic converter combine the carbon monoxide with oxygen and produce carbon dioxide. That's a harmless gas. Now here, the option A is wrong here because in the product side, it is nitrogen oxide. This is harmful gas. And the B is a correct option when the carbon monoxide is a harmful the nitrogen oxide is a harmful gas. So that's converting into the nitrogen and carbon dioxide. These are harmless gases. So B is our correct option. C is the wrong Y because in the product side, there's a harmful gas, carbon monoxide, and the D is the wrong Y because in the reactant side, both gases are harmless. So that's why the B is our correct option here. The question number 31. An alkene is represented by the formula. This is a CH3, CH, and CH2. So that's the formula of alkene. So that's our basically propene, or we can say prop1ene. So which name is given to this type of formula? So we can see there are different forms of the formula are given there. A structural formula shows how various the atoms are bonded. And it's basically the structure formulas are given the information about either it's a single bond represented by the single line, and if it's a double bond represented by there's a double line, and it's the triple bond is there. So in this way, this is one form. So it's basically, it is structural formula. What about the display formula? This shows all the bond between every atom in a compound. So for example, hydrogen and a carbon and all bond, all type of the bond. So that's why this is our display formula. Now, empirical formula is giving simple whole number ratio between carbon and hydrogen. So for example, we have a molecular formula C3H6, and this will convert into an empirical formula and the simple whole number ratio CH2. While the general formula is giving up a homologous series that's used to figure out how many number of the hydrogen are present with the reference of the carbon. So we can compare, for example, for ethene or alkene, the formula is CnH2n. So in this way, that's the correct option is the D here. That is the structural formula. We're going to move to the question number 32. What is the structure of propanoic acid? So in the propanoic acid, you can see that A is a correct option. Why? Because these are 3 carbon, and the carbon number 1 contain carboxyl group and hydroxyl. This is carboxylate group. It's attached to the carbon number 1 is that. So that's why it is propanoic acid. What about the B option is a wrong? Why? Because there are 4 carbon attached with a carboxyl group. And in this way, these are total overall 4 carbons are there. So that's why this is butanoic acid. So that's why it is wrong option. And in the same way, the C, so you can see the total number of 3 are there, but functional group is hydroxyl. So that's why this is alcohol, not carboxylic acid. So that's why this is propanol. And in the same way, the D is butanol, not carboxylic acid. So A is our correct option here. Question number 33. The butane react with the chlorine in the presence of ultraviolet radiations. So what is the equations for this reaction? So we can see that there's a butane, and this butane is reacting with a chlorine. So ultraviolet radiations will break the covalent bond between the chlorine, and that will become in a radical state. This will take on a hydrogen and produce hydrochloric acid. While the alkyl group, this will react with the chlorine and produce 1-chlorobutane. So in this way, the overall reactant or butane react with the chlorine and produce 1-chlorobutane, and this is the substitution reaction, and that's going to produce hydrochloric acid. So we're going to say that which option is representing this reaction. So option A, this is the butane reacting with the chlorine, and this is producing the addition reaction. So that's our this is both chlorine are aided with that. So this reaction only ethene or butene can give this reaction. So that's why it is wrong option. So the B is a correct option. Why? Because the butane is reacting with a chlorine molecule, and that is producing 1-chlorobutane and hydrochloric acid. That's a correct statement. Now, the C is a wrong option here. So that's also producing a wrong product. And the D is also producing a wrong product. So the chlorine in the presence of ultraviolet radiations with the alkane is giving the replacement of the hydrochloric acid. It's producing hydrochloric acid and the chloroalkane. So that's why B is our correct option here. The question number 34. A hydrocarbon P is cracked to make a compound Q and hydrogen. Now, this compound R is formed by the addition polymerization of the compound Q. So here, the step number one, this basically cracking is what? When we are breaking down the higher hydrocarbon chain into a smaller hydrocarbon chain. So this process called cracking. So we are performing the cracking by using catalyst or by using heat. So here, the first step is what? The P is basically the alkane. Why? Because if it's removing the hydrogen, and this is a dehydrogenation process, mean we are removing the hydrogen from there. And in this way, that will produce a double bond between two carbon. And that will produce alkene. Why? Because we are removing hydrogen, and the hydrogen can only possible to remove from alkane. So that's why there's a larger chain, and we are breaking down this larger chain into two smaller chain by removing hydrogen gas. So, and in this way, that's producing two ethene. And in this way, these ethene molecule can go with the addition polymerization reactions we got from the question. So there is an addition polymerization reaction. It's only possible with alkene. And in this way, by addition polymerization reaction, double bond will split into the single bond, and this will convert into an alkane once again and produce a long polymer of alkane. So in this way, the P and R are alkane, while the Q is alkene according to the given situation in the question. So that's why the B is our correct option here. We're going to move to the question number 35. Which substance are structural isomers? So structural isomers mean the molecule which have a same molecular formula, but they have a different structural formula, or they have a same number of atoms, same number of different type of atoms, or same molecular formula, but that's the structure or the arrangement of these atoms is different. That is called structural isomers. So we can see that butene and the propene. So here, one is it's basically a butene, second is a propene. So butene contains what? 4 number of carbon, while the propene contains 3 number of the carbon. So number of carbon and hydrogen are different. They have a different molecular formula. So that's why they cannot be isomers of each other. So the B, we can see ethyl carbonate, and there's a butanoic acid. So this ethyl carbonate contains C4H8O2, and in the same way, the butanoic acid that contain a different functional group, but the number of the carbon, hydrogen, and oxygen are same. So that's why these two are isomer of each other. So we can understand this phenomena by in this way. For example, if you can see that this molecule, so first molecule we can see this is our ethyl. So that's our molecule. First we have ethyl ethanoate. So now in this way, ethyl ethanoate. So first we have, for example, ethanol reacting with the methanoic acid, and that's going to produce by the condensation reaction. This is ethyl ethanoate. Now, this molecule contains the same number of carbon, hydrogen, and oxygen as compared to butanoic acid. So, for example, you can compare to the butanoic acid. So, in this way, they have a different structural formula, but they have the same same molecular formula. So, in this way, that will be the correct option. B is our correct option here. So here we have done. What about on the option C? And in this option C, the methyl methanoate and the ethanol. So this way, the same. The number of the carbon is the same. What about the number of the hydrogen are different? What about there's the ethanol? There are the 6 hydrogen. What about the methyl? So ethanoate, there are overall 4 hydrogens are there. So number of the hydrogen are different. So that's why the molecular formulas are different. Now, in the same way, the D, so we have one is a propane, one is propene, and one is there is a propane 1O and butane 1O. So one is propanol, other is a butanol. So number of the carbon are different, and in this way, these are not structural isomers of each other. So B is our correct option here. The question number 36. The ethanol is produced by the catalytic addition of a steam to ethene and by the fermentation method. So there are two processes. For example, the first process you can see on the right side, the ethene is reacting with the steam water molecule and in the presence of catalyst and 60 atmospheric pressure. So this will aid the water molecule in that, and this will produce one. Double bond will split into the single bond, and the carbon number 2, this will take the hydrogen in, and in this way, that's going to produce what? CH3 and CH2 and hydroxyl. That means that's going to produce alcohol. So by use of catalyst and 60 atmosphere pressure. Second, the fermentation reaction, we're going to take the glucose and the yeast molecule. So this will break down this glucose. So in the presence of 25 to 35 degrees Celsius, and that produce alcohol and carbon dioxide. So these are conditions are required for this. Which statement is correct about the situations of 1 and 2? So you can see that the both process use similar amount of energy. So fermentation requires lower energy as compared to the catalytic additions. So that's why it is that's the wrong option. In the same way, the B, the both process are the catalyst. So both process use a catalyst. So for example, you can see that there is the catalyst we are using in the first process, catalytic addition. What about the yeast is also using enzyme to break the glucose molecule? It also biological catalyst. So that's why the both processes are using catalyst. So C is the wrong option. Why? Because process 1 used the temperature 25 to 35 degrees Celsius. So it's used in process 2, not in process 1. So in the same way, the process 2 used the pressure of 60 atmospheric pressure. So it's used in process 1, not in process 2. So that's why B is our correct option here. The question number 27. The two monomers shown can be used to form the condensation polymerization reactions. So these are two monomers, and one monomers contain carboxylic group on one side, other contain amino group on one side. So carboxylic group and amino group, they are react together. So one will release the hydroxyl, others releasing hydrogen, and that's producing a water molecule. So in this condensation reaction, water molecule will release by condensation reaction. So A is our correct option here. Dilute hydrochloric acid is titrated in a conical flask containing sodium hydroxide solution. So this base is there in a conical flask. And what about few drop of methyl orange used as an indicator? Which piece of apparatus is used to aid hydrochloric acid? So we are using the burette. So to transfer the hydrochloric acid, what about we use the conical flask to that contain sodium hydroxide, which is aided by the pipette. So that's why here the correct option is B. The burette contain acid. So question number 29. Here the question is 29 related to the chromatogram obtained from chromatography experiment on a substance X. So that value is given there. For example, we have the value. Now, first we have a baseline, and second we have a solvent front. And what is the retention factor on the basis of this given value? So the retention factor is what? The distance moved by the solute divided by the distance moved by the solvent. So here, first, the distance moved by the solute is given from the baseline. It is the 6 centimeter, while the distance moved by the solvent, that is the by solute plus to the front of a solentron. So we're going to add this 6 plus 4.7. This will become 10.7. So we're going to find the 6 centimeter divided by 10.7. That answer will be 0.56. C is our correct option here. So question number 40. The element X burn in air to form an acidic gas, which decolorizes the potassium permanganate. So in this way, we're going to see that, for example, if there is any gas is burning in air and that's producing an acidic gas, for example, the carbon will burn in air and that's going to produce of a carbon dioxide, and this will react with the water and produce carbonic acid. But this gas, when it will make the oxide, obviously these are acidic oxide, but this is not decolorizing the potassium magnate. So this is going to be, that's a wrong option. Why? Because carbonic acid is not reacting with the potassium permanganate. So in this way, that's the one part. In the same way, we have option B, the nitrogen, that's reacting with the oxygen and produce the nitrogen oxide. This further react with the water molecule and produce a nitric acid. But this nitric acid also does not decolorize the potassium magnate. So that's why it is a wrong option. In the same way, magnesium oxide is not decolorizing. So now when the sulfur react with oxygen in air and produce sulfur dioxide, and in turn, that will react with the water molecule and produce sulfuric acid. This sulfuric acid can easily decolorize the potassium magnate. So that's a knowledge-based question here. So D is our correct option here. So we have completed this paper, and hopefully it will be helpful for you. If you didn't understand any questions, so you can write your question in a comment box. I'll try to answer your questions. So thank you. Thank you very much.